For exercise 14, part E, we see the ether oxygen right here. We want to know how many carbons there are on each side. There's 2 on the right. There are 1, 2, 3, 4, 5, 6 on the left. Because there are more carbons on the left, that carbon chain on the left is going to be the backbone. And everything outside of it will be treated as a branch. Now, we just saw there are 6 carbons here, 1, 2, 3, 4, 5, 6, and the prefix for 6 carbons is hex. So this is going to be hex. If you look at the bonding there, we do have at least one double bond, and when you have that, the infix is En, so hexene. And for the suffix, the ether is not represented in the suffix, and everything else is just a carbon and hydrogen. So the suffix here is going to be E to represent that you have a hydrocarbon, just carbon and hydrogen. So hexene. Another thing you'd want to notice is that this is going in a ring, and whenever a carbon chain is going in a ring, you add cyclo in front of the name for it to say, yeah, all the other information we just talked about, but also it's going in a ring. So that's cyclohexene. Okay, next our branch. We have 2 carbons here. The prefix for 2 carbons is F. We have an oxygen, so that's going to be represented by an oxy, so F-oxy. Now, how do we want to number the ring? Well, we actually have 2 things to consider here. One is the double bond, and the other is the branch. So which is more important? Now, there may not be it may not matter in this particular molecule, but maybe in a molecule that's slightly different, it would matter. So if you had to give a number to a double bond, a lower number to a double bond or an ether, which one should get the lower number? Well, notice we have our ether here. This is the importance of the ether, and double bonds are above it, the alkene. So if you had to choose, the double bond should get the lower number. But in this case we don't have to choose, because even if we do give the double bond a 1, we could do it in such a way that the ether also gets a 1. And then you would number it counterclockwise, because remember, when you number alkenes, you always have to cross the bond. So 1 where the bond starts and 2 where it ends, the double bond ends. And so this is going to be 1-ethoxy and cyclohexene. Now, you don't have to say 1-cyclohexene because because it's the highest priority functional group there. It's assumed to be at number 1, but it is going to be 1-ethoxy. So 1-ethoxy cyclohexene, beautiful name. That is this molecule here.